1, 2, 3. Perfect. Hey there. So today we have ourselves a MacBook Air that has no backlight. And this one looks like there's no display, but whenever we shine a flashlight on the actual screen, we can tell that the backlight is just not lighting up, but the display panel is actually turning on. So what we were able to very quickly discover with this MacBook is that it is liquid damaged. And from the story that we were told by the customer is some Fanta, the soda, had been spilled into the computer. And you can kind of see some of the sticky residue right here. But mostly in this area where the display connects, we're just getting no backlight at all. And I'll show you one way how we can diagnose if we have a no screen issue versus a no backlight issue. So the first thing we're going to do is just actually plug this into power and see what kind of output we get on the MacBook screen. No display versus no backlight are two completely different diagnostics. But one way that we're able to determine that this one has a bad backlight is that when the device is turning on, if we get a flashlight, we can actually shine on the back of the Apple logo here, and you can see with my flashlight, I can actually see the Apple logo loading up. So the display is turning on, we just have no light. If this was a no display issue, then we wouldn't get anything at all whenever we shine a flashlight through the backside of the clamshell where the Apple logo is at. Now, the unfortunate thing is the newer MacBooks, you don't have this window here anymore, so you can't diagnose as easily with a flashlight by shining in through the backside. You now have to shine directly onto the display and try to see if you can see anything popping up at all on the display. So let's go ahead and start pulling the logic board out so that we can measure to see what exactly has failed. And wrong camera we have here. I just need to turn that menu off on our microscope camera. So first thing we want to do is make sure the battery is unplugged, which this one already is. Now let's start by pulling out the rest of the logic board. And I know for a fact that one of my technicians has already gone ahead and connected a new display, or a used display just for testing purposes, to verify that it's not the actual display itself has failed, but the actual backlight circuit. One thing you can also test before you start pulling the entire logic board out is where the short, if there's a short, is there a short on the backlight circuit or is there a short on the actual screen? So let me go ahead and show you real quick how to do that before I pull out the main logic board. So what we'll want to do is go ahead and get our multimeter, and I'm going to put it into continuity mode, which is the picture of the sound wave right here. And basically, whenever we touch these probes together, they beep. So if I touch ground and touch another piece of metal like here, we're going to beep. So what we want to check to see is if there, I'm so sorry, that's really loud, if there's any obvious short to ground. So let's switch over to the microscope camera and inspect the Fanta damage we have here. And let me get this in focus for you all. So those are some pretty big capacitors right next to our display cable. And there's a fuse. This is our backlight fuse, the one that starts with a P. And what we're going to do is measure to see if there's a short to ground on the fuse. And if there was, I would be getting that type of noise, but we're not. So now let's make sure the fuse is actually functioning. It is. So a fuse is nothing more than a wire, so if it was blown, it wouldn't beep. But the fact it's beeping is telling me that the wire inside of the fuse is still perfectly fine. So there is no short here. If there was a short, we would test and see on what side of the fuse it's located, and we would also test with the screen both plugged in and unplugged. In this case, there is no short. So let's continue moving the logic board. Hey Joshua, thanks for joining us for the live stream. I have the same soldering station and multimeter, good tools. It is a nice soldering station, I definitely agree, and a good multimeter. Josh works at another repair shop, he's another really good technician. But it's been a while since I've done a MacBook Air backlight repair. And I love working on the A1466s. This is arguably my favorite MacBook to work on. a lot less open-ended issues like what we run into with the M series or the Apple Silicon series chips and the T2 chips. And let's continue with the logic board screws now that the fan has been removed. So yeah, wasn't just any soda. This one was specifically Fanta. Or in the South, as I was arguing with my employees, Fanta. But it's pronounced Fanta. Like the old ads, the Wanta Fanta. Don't you wanta? But everyone here in South Carolina calls it Fanta. Okay, so the logic board has been removed. And we're out. Now, I'm not sure if any of the Fanta got inside of the daughter board right here, so I'm going to go ahead and pull that out. Do you use hot tweezers with your station? I don't like the ones that the Hakko makes for it. Any recommendations? I actually do have the Hakko tweezers. These specifically, the FM 2023. These have actually been pretty good for me. I've had these since 2017. They've been a pretty good set. I have no complaints personally. I haven't experimented with any other hot tweezers, so I can't really say from experience of other brands. But those have been pretty solid. I've changed out the tips several times throughout the years. All right, so let's go ahead and set all this in our screw tray to the side. And now let's just give a visual inspection. I have a suspicion that our backlight driver on the back of the board is probably going to be where we have some corrosion buildup. Okay, so right here, let me get this in focus. That is our backlight driver. And surprisingly, it actually looks okay for the most part from this angle. Let's inspect the rest of the board in this area just to see if anything else may have got some Fanta spilled into it. Our SMC area looks okay. So far, so good. And we have a little bit of stuff right there, but I think we can just simply clean that up. I don't think that's actually corrosion buildup. And the rest of the board looks to be okay. So most of our damage then is going to be in this general area. So what we want to test is on what part of the circuit are we not getting power. So now what we're going to have to do is go ahead and head over to our schematics. Let's pull that up, and I've already got it right here. So this is our flex board view by Paul Daniels. You can download this from pldaniels.com as well. And this specific board is the 820-00165, which is going to be the logic board made from 2015 to 2017. However, this logic board backlight circuit is identical to the 2012 A1466 to the 2017. So it's pretty much all the same circuitry, how you look at it. So in order for us to properly test out the backlight circuit, we actually have to have the screen connected, because if the screen's not connected, the computer is going to be smart enough to not send power to the display. So for this, it makes the repair just a little tricky, because we have to plug in. So I actually like to use a donor screen that I can kind of maneuver, and I have a couple of screens laying around. Let me see if I can find the one that one of my coworkers was using. I'll be right back. I think it actually got put down here with the rest of our broken screens. All right, here's a perfect candidate. So this one is one that clearly has a crack in the panel, but the LCD backlight should still be all right. So let's go ahead and connect that. We have a water damaged MacBook we may be sending your way tomorrow. Okay, we'd be more than happy to help out in any way that we can. Appreciate you guys always keeping us in mind. All right, so our screen's connected. Now, I don't want to go ahead and plug up the MagSafe power supply while this is touching the metal frame. So I'm going to grab just a silicone sheet that I have here to lay on top of the screen, separating the logic board. That way we don't run the chance of potentially shorting anything on the backside of the logic board. Now let's go ahead and grab our power supply. Now again, I still have my other multimeter that usually pops up my readings up here in the corner. That is at my home office. I don't have it here, so we're doing everything the analog way. Now another thing that kind of makes this tricky is with the logic board laying on top of the screen like this, we are activating the Holofax sensor to act like the screen is turned off, or the screen is closed, the lid is closed. But let me see, with it currently connected, what kind of reading we get on this fuse. So I'm going to have this in DC voltage. We're getting about 8.6 volts. So that normally means that we are getting power, but something is not boosting on the, we're getting power from the backlight circuit, but something's not boosting the power to the 50 volts I would expect from the actual driver chip. Now, that might be a bad diode, and I'll just show you exactly where that is on the schematics. So right here, I just went ahead and measured this particular fuse, F7700. So here is our backlight circuit for the logic board. And I have everything kind of inverted right now. But what happens is we send PP bus right here, which is 8.6 volts, through. So I was wrong when I said it's not boosting. And then we go to this MOSFET, which goes to an enable switch. And then we go through a voltage divider right here. That goes to another set of MOSFET. It looks like two MOSFETs, but this is one single MOSFET, Q7707. And we have external display port, or I forget what the E stands for, but display port backlight enable. And then we also get PLT reset L, which is a signal coming from our system management chip. But ultimately, U7701, this is going to be our backlight driver, which the driver itself looked fine. So how this basically works is we get 5 volts, PP5ESO is going to go into voltage in, V in, into U7701. This is the power chip essentially for our, or the power rail for our powering up our U7701, our backlight driver. Then we're going to basically get an enable signal right here, backlight enable, that tells this to then boost power to PPV out switch LCD backlight feedback. Nope, my bad. It's going to boost up here into LCD backlight boost right before we get to this diode here, D7701. So really what I need to measure is what kind of voltage do we have on the other side of this coil? Are we getting any type of power coming from this coil, either from the driver side or from PPVN SO switch LCD backlight? So let's go ahead and take a look there. U7701. I hope all that makes sense. It's been a minute since I've done an in-depth backlight repair video, so my mind is kind of a little scattered, so I'm trying my best to break this down as best as possible. And U70 or L7701 is going to be this giant coil, and we want to measure on this side. So let's go back to our microscope now. Actually, truthfully, this is such a large coil, we don't even need our microscope. It's just that guy right there. This giant square right here. So let's go ahead and Measure that. And I'm getting 8.6, which is our PP bus line. So let's take a look at this and see if I can understand what's going on. So that is going to be the same voltage as PP bus. And the fact that we have power right there usually means that the backlight driver is not doing its job. It's not actually turning on. So if we were to look at this real quick, we have PP bus goes into F7700, which is our PPVN SO switch LCD backlight FET. I forget if this is P channel, N channel. I want to say this is a P channel MOSFET with this arrow going up away from the gate on pin 3 of this MOSFET. So basically, this is supposed to have 8.6 volts and LCD backlight enabled divider. In order for PPVN SO switch LCD backlight FET to have power going through it, the LCD backlight enabled divider L, or low, I'm going to probably butcher this, is supposed to generate a lower signal, a lower voltage line, which is going to be coming from our LCD backlight enable line. Basically, it's going to, this turns into a voltage divider. When you have two resistors and then basically ground right here, this is going to divide voltage. So being that this is an 8.6 volt rail, once this is enabled, the LCD backlight enable low, this line is supposed to drop to something lower than 8.6 volts, which would then allow PP bus 8.6, even though it says 12.6, don't read the schematic, 8.6 to go through PPVN SO switch LCD backlight FET, which eventually turns into this guy, PPVN SO LCD backlight FET. So this tells me our enable signal coming from our SMC is operating like it should. This is sending power through this MOSFET like it should, but for some reason the backlight driver is not boosting the power to the LCD backlight boost to D7701. I hope that makes sense. Hey Pedro, thanks for joining us. All right, so with that being said, let's measure and see what our diode reading, if our diode is operating like it should, if we're getting a measurement of a diode from between one side and not on the other, or are we getting a diode reading on both sides of that diode. So let's go ahead and now go under the microscope camera and unplug our power because we no longer need that. And so there's all of our gunk. And that is the diode that we want to look at. That's D7701. And actually, I already see what our issue is. You see that little bit of rust right there? That rust is a via, which is a trace that goes through one side of the board to the other and communicates or finishes the rest of our line right here. This is our via actually right here, PPV out S switch LCD backlight or feedback. Our via is actually going to connect right here, and being that it is pretty much oxidized away, this entire connection is gone. So if the feedback line is gone, let me make sure I'm looking at the same thing here. Yes, I am. Okay. So if the feedback connection is gone, then the backlight driver can't properly communicate how much power is actually being put out. That's why it's called the feedback. It communicates to itself, hey, I'm basically putting this much voltage. So if it can't communicate, as a failsafe, it just doesn't turn on. It doesn't send out any of the power, which then turns into our LCD backlight. So that, I feel very confident, is actually our issue. So what we're going to have to do is repair that via, that tiny little trace. So what I'm going to do is I'm actually going to remove, we're going to replace these capacitors while they're functioning. They're not pretty. I don't like them. So let's go ahead and remove these caps, and I'm going to get this coil out of the way just so I have a little bit more wiggle room to work with. And let's turn on our fume extractor. I hope all this makes sense. Backlight driver, which is responsible for boosting power, is not boosting like it should because the feedback line is missing. If the feedback line is missing, for failsafe, the backlight driver, it just isn't going to actually send out any power. That way it doesn't accidentally send out too much power and kill something in the process. So let's go ahead and make sure we have all the right attachments for our rework station. We use a quick 861DW. This is this one I actually bought from Rossmann Group, store.rossmanngroup.com. And let's see, can I? Yep, I'm gonna use a mix of the rework station as well as the hot tweezers. That way I can apply heat directly to the board while also hitting it with the rework station. Now this coil here is probably fine, so we're gonna keep that. But the capacitors that are covered in red Fanta, we're gonna get rid of those. Or not red Fanta, what would it be? Would it be cherry Fanta? Or is it strawberry Fanta? I know there's like a limited edition that you can only get at, I think, Zaxby's. Some restaurants. So those have been removed. Let's clean up the area. For that, I use a mixture of alcohol and acetone. So let's start first with acetone. And let's hit that with a little bit more. Oh yeah. So you can see that line right there, that via is just completely gone. We have no confidence in those capacitors. Not that I would want to put a warranty on. They will come back more than likely. So we are just going to replace those capacitors. Alright, now that we've cleaned up the flux with the acetone, let's hit it with a little bit of alcohol. Yeah, that's just 100% rust. So now that we've cleaned up the area and we've exposed our operating area, I'm going to get a scalpel with a very sharp tip and see if I can kind of dig into there. See if we can expose some of that via. Yeah, it's all just kind of crumbling as I'm barely touching it. It almost has the consistency of like brownie mix, if I had to describe. It's very, very soft. So ultimately, the Fanta was just so corrosive, it just ate away. Now, the story that I believe I heard from another tech, because admittedly I didn't talk to this client, was that the soda was spilled into it, and they continued to use it for a bit. So I'm not sure how long the Fanta was actually spilled into this computer, how long ago it was, but it definitely worked its way with the, this is a very high voltage line. It can usually put upwards to 50 volts. It's actually, I think, the highest voltage line on the entire computer. So the sugar was just being hit with up to 50 volts of electricity and was really like caramelizing it. It was cooking it. And yeah, this whole entire trace part, you can see that tiny dot right there is what's left of the via, but everything else around it is just brittled fiberglass. So, I think we're at a good spot. What I'm gonna do now is apply a little bit of solder onto both the via, and you can see I've actually exposed where the via goes to. And I have some neat pre-cut out jumpers jumper wires that I'm going to use in this instance. So now, let's go ahead and switch our tweezers out to our micro pencil. I like working with a micro pencil when I'm having to do via repairs. And let's tin this up. And this is a very, very small via, so I can't really zoom in any more than what I'm at. So it's not good to see on the camera, but it's there. It is a lot better in person. So now we're going to grab some jumper pads, and Pedro is exactly right. The Wiley pads are what we're going to use. It's just and these we just picked up from Mobile Centrics probably about a year ago, but I've done several repairs with them now. But it's just this copper sheet that has a whole bunch of lasered, etched out tiny jumper pads. I'll get one of these cameras right one day. There we are. So let's see which one's going to work best. Probably... let's go with that one right there. Yeah, judging by the size of the pad, let's do that one. Okay. So now I got to pull this out. So you can see that it's just a tiny piece of copper that already has the shape of a pad with a jumper wire attached to it. I'm just going to use my scalpel here to try to extract it. My hands are shaky tonight. I'm very hungry. It is definitely dinner time. So once I'm done with this repair, I'll be immediately grabbing something to eat. Okay. So now, let me try to set this down and readjust my work area. I want to try my best to line up this tiny pad on top of that little bit of solder I have on my via. Customer paying for expedited? Nope, we're just pretty caught up for logic board repairs for the most part. And the only time I can do board streams, optimally, in my opinion, is when we're closed. That's when I'm not getting phone calls or interrupted with other inquiries. And we should have a good connection there. Now, my via has been soldered onto this new replacement pad. Now I gotta apply a little bit of solder right there to part of the exposed trace. I'm trying to do this without heating up the entire new jumper pad, because I don't want it to melt the connection I have on the via, which I guess will be okay because we're going to have to apply heat anyways to solder these capacitors back. Okay, now let's trim up the excess connection, or the excess wire coming off of it. And let's see if there's any way we can do a continuity test. I'll try not to interrupt you in the future. You're fine. You don't interrupt me. It's usually the phone calls from the accountant or telemarketing or anything else when it comes to running a business as well as working in the business. That kind of takes me away. So fortunately, everyone else is closed right now, so I don't get those type of phone calls. Okay, where were we at? We were looking for the point to test for continuity. That's going to be a little tricky because the via goes directly under U7701. So there's not really an easy way for us to test if we have continuity, because we would have to put a multimeter underneath our backlight driver. We could have measured the difference in diode mode before I applied that. And it's exactly what Pedro was saying. So, admittedly, I don't know what a diode mode reading of a good connection is. I could always compare it to one of my donor boards I have here. So here we got a connection of 0.56. And I'm not sure if that's what it is just because the reading we're getting on this side of the diode, or if that's because the actual repair was successful. What I'm going to do now is just go ahead and replace these capacitors, put our coil back, and see what happens. And if it doesn't work, we know that we just need to touch this up again with a little bit more solder. And let's go ahead and apply some fresh solder here. See, the smart thing to have done would have been able to got a reading of the connection by itself, the via by itself, before I actually attached it to this trace. Second thing you could do is just measure what the reading is to a known good board. Now, I'm going to have a different reading if I were to do that because I don't have these capacitors installed. So now I need to find a donor board. I'll be right back. And it appears most of my MacBook Airs are actually missing those capacitors because of previous backlight repairs. We got one. All right. So let me just get those capacitors out of the way. Here's the donor board that we have. Now see, if I measure this via, I'm going to get a completely different reading. I was getting a 0.5. Here I'm getting 0.6. And I would imagine the difference is because these capacitors are still attached. So to me, I think that's close enough to say that the via is connected. All right, let's switch back to our hot tweezers. And there's one capacitor. Let's take the other one. Well, I've got to go. Sending that your MacBook away tomorrow. Awesome. Well, you enjoy the rest of your evening. Thanks for joining for this part of the stream. I will talk to you soon. All right, let's line up the replacement cap. And start soldering back into place. And let's do that same method where we use the hot tweezers and the rework station. That way we can really isolate our temperature on just one part of the board instead of heating up the entire area. So we got that capacitor in place. Now let's grab the next one. Pager says perfect to her diode reading, so I have faith that we have fixed this one. Because if Pager says so, then it's definitely got to be. I've had his blessing. Alright, and let's just apply a little bit more solder right here. Make sure it's got a really good connection. And last but not least is going to be our coil. Now our coil is perfectly fine. Coil, nothing more, is exactly that, just a giant wound up coil. It's very rare for them to fail. It's never the coil until it's the coil. But it's almost never the coil. It can be. I think I've had maybe 2 MacBooks ever where the issue was the coil. So it's not impossible, but it's very unlikely. Okay, and now just to make this look all nice and pretty, let's put a little bit more solder here. And let's test our new via that we have here. Make sure that we're still getting a diode mode reading. And we aren't. So when I heated it up, I actually desoldered part of the via underneath it. So now, let's use our hot tweezers again. Not hot tweezers, micro pencil. And then just like before, I'm going to just touch it real fast. And let's see if we're getting that reading again. And I don't think we are. Now, is that because the board is hot? It's because I was doing diode mode backwards. That's why. We're fine. In diode mode, you have to put the red probe on ground. And I know that, so I don't know why. I messed up. It's because it's a live stream. Trying to do board repairs while other people watches. It makes me do silly things every now and then. Alright. Let's go ahead and turn off our fume extractor. We don't need that anymore. And let's grab that donor screen. Now, same thing as before. We're going to grab this silicone sheet that we have here so we don't end up arcing anything. Make sure you plug in the EDP cable correctly. If it's got a little white dot on it, it's upside down. All right, and now we connect our charger. And if this was successful, we should have some sort of light. Which is not the case right now. Question is the computer even turning on? Still nothing, and it doesn't even look like this panel is even trying to turn on. Let's see, let's revisit and see what's going on here. And again, it could be because I don't have the logic board laying the other way, so we might be activating our Halifax sensor. Let's see. what kind of voltage do we have on the other side of this coil now? That's not right. This said 0. So either one of these capacitors I had just attached is shorted, which is not the case, or the computer is not turning on. Now, this is a 60 watt charger. Just to make sure that's not messing with us, I'm going to grab an 85 watt charger. And let's see. And so we have an 85 watt charger here. We have green lights, so we're communicating with our SMC. Still nothing on the backlight, so let's check the backlight fuse and see if we still get PP bus. We do. And we're pretty much getting nothing on our multimeter here. But the computer is turning on. Let's just make sure we don't have a loose connection here, because now we're not getting 8.6 volts on our fuse. Instead, we're getting nothing. Honestly, I'm kind of happy that this happens, because I like troubleshooting what to look at whenever you experience something like this. Let's make sure the Hall effect sensor isn't messing with us. That's just the magnet that's built into the screen that turns off the display. So I'm having the board lifted up so that it's not touching anywhere near the magnet. And this is where the broken LCD panel is at, but we're still not getting any type of light. So either we have now fixed the feedback sensor, but the feedback is telling the driver to not turn on. All right, MacBook. Let's see. So now that we have moved you, did you make any difference to our coil? Nothing at all. And getting 8.6 volts on both sides, so our fuse isn't broken. So now I want to go back and check and see what is going on with our LCD backlight switch line. We may have a bad driver now that we've got this connected. And let's see exactly where that line is generated again. So again, if we pull up our schematics, right here on this coil, we were getting 8.6 volts. And the fact that we're now getting nothing tells me that we're not even getting PPV in SO LCD backlight, which that is typically coming from this guy right here, Q7706. So we have a voltage divider here. Basically, when this voltage drops, this is going to allow 8.6 volts to go through. And we're not getting that anymore. So what we're going to do is we're going to go to Q7706 and look and see if power is actually coming out of that. Q7706 is right here, directly next to our fuse. Back to the microscope camera. MacBook said, that'd be too easy tonight. You're not going to be able to eat. Okay, so this is Q7706. And what we want to measure is 8.6 volts. I have this unplugged, just to let you know. Now, 8.6 volts is going to be coming through here, and it's supposed to be coming out somewhere else. It looks like right here. specifically, which we measured on this side of the circuit. We didn't have that, so in theory, this isn't opening up like it should, or this isn't allowing 8.6 volts, so we probably actually have to inspect our voltage divider. Knowing my luck too, this is all just a bad display panel too. That would be my luck. You know what? Let's test that real fast. I'm going to go back to the client's display because I actually don't know if this display has a good backlight. It does say test only, but this was down in a bucket of broken screens. So it could actually be a bad display. The MacBook is messing with you. Well, that's the thing with this line of work, is that there's never straightforward answers. There's not just, hey, just replace this one thing and it will work. It might work, but you have to use your brain from problem solving. And growing up, I played a lot of problem solving video games, which I credit to why I do what I do. Okay, so the screen's plugged in. Let's see if we have any different results. See if the LCD panel even turns on. Because the problem with a broken screen is that you can't even check to see if the display panel is even turning on. Yeah, that was definitely the situation. So now we have a working backlight. And I'm going to plug in a test drive just to show you. So that means that my screen that I was testing with was in fact a bad screen. So here I have myself a test drive, which just has a whole bunch of different operating systems. So I'm going to hold the option button down real quick, and it should load a whole bunch of different partitions. Testing your patience. If you don't have patience in this line of industry, you are in the wrong industry. Usually it's a good excuse to just kind of walk away and get something hot like a coffee or a tea. So I'm still waiting for my drive to connect. Still just kind of reading everything. But an unorthodox test is you can actually kind of gently poke the LCD panel and you can see the backlight kind of illuminate. And I think what we're going to have to do is actually just SMC reset this one. Oh, you know, the option button's not going to work if we don't have our keyboard plugged in. So this has, I think, a copy. The first partition is install macOS El Capitan. So that's kind of what it's booting into right now. But there we have a working backlight. And just to show you that that circuit is working without closing this all the way, what I'm going to do is put our multimeter back into voltage mode. DC voltage, we're going to touch the same coil and we should have something a lot higher than we did before. On the other side of our diode, my bad, not our coil. Our coil is going to be PP bus, which is 8.6 volts as you can see there. But on the other side of our coil, 24.20 volts. So the backlight circuit is working like it should. This is booting up. This ultimately was just a situation to where there was so much oxidation built up that it rusted away the via. And if we look back on our schematics here, the via is this tiny, tiny little trace that connects the back side of the logic board, which is where the backlight driver is located, U7701, directly to this part of the board, which is going to be our PP HVSO switch LCD backlight. This is our feedback line. If our feedback line is not present, the backlight driver just says, hey, I don't know if we're sending 1 volt or if we're sending 100 volts. Just completely disable the backlight driver from even sending power out. So what we did is we just put a jumper pad right here where that was completely severed. So the feedback sensor is talking like it should. Now, the little holdup that you guys all just saw was a matter of not that the circuit was bad, but that this screen, the broken screen that says test only, that was in a bucket of MacBook screens, is bad. Go figure. Proof's in the pudding right here with my overhead camera. Backlight circuit is fully working. So that is a successful board repair. So this obviously needs to be cleaned up. There's still some more Fanta on there, more corrosion. I'm going to leave that as a honeydew list for me for tomorrow and go home and get some dinner. So I appreciate you all for joining me for this live stream. And yeah, I will see you guys in the next one. Have a wonderful evening. Bye.